All right, good afternoon, grade nines. I hope that you guys are all having a productive Tuesday so far, and that you're ready for us to get started today, guys. We are now, I believe, on the 14th week of tutoring of the year, so welcome to the 14th lesson. For those of you that are new and this is the first time that you've decided to join one of these lessons, welcome to all of you. And to those of you that have been here before, welcome back for another lesson, guys. So we are back again to continue on with another topic in the math syllabus for you guys in grade 9. And there are obviously quite a lot of different topics that we could choose to cover and spend time discussing. But last week, grade 9s, we changed gears a little bit and shifted from dealing with quite a lot of the algebra that we've been discussing for the last few weeks over to this area, this concept of measurement, right? Now we know that when it comes to shapes, there's a lot of different things that we need to be able to measure. So we talk about measuring the area of different 2D shapes, the perimeter obviously as well, but that's not as important as we move through the higher grades now. We've obviously also touched or need to touch on surface area and volume. So that's where I'm hoping we can get started today. We want to take a quick chat, take a second to quickly chat about what surface area and volume are, and then we're going to take a look at some examples. Now, this still falls under the broader topic of measurement, and I wanted to quickly take a second to just give everyone a chance to join in on today's session. So I see that there are a few of you here, which is awesome, guys. It's great to have you. If you wouldn't mind, I would really appreciate it if you could please type your first names into the comment box for me, just so that I can see who's here. It just allows me to get familiar with all of the students that attend relatively often, right? And it allows me to understand how many new faces we have joining us this week. So I'm going to get started by sharing my screen with you guys, just like I would any other day. I'm going to check that you can see everything, and then we're going to get started. We'll take a few seconds to quickly discuss what volume and surface area are, and then we'll dive into our examples. This is a very practical section of work, guys. So there's not an awful lot of theory for us to discuss. With that being said, you guys do need to understand the names of your different shapes. You need to be familiar with all of them. So if I speak to you about cuboids, or we chat about triangular prisms, these are words that you need to be more or less familiar with. Okay. So we're going to get started. Just give me 1 second to stream my screen, please, guys. If you have any questions, you're more than welcome to ask. That doesn't change. It's the same every week. If there's anything you guys would like to know, please just type a message into the comment box for me, and I'll answer it as soon as I see it. But you should be able to see my screen on your screen shortly. I'm scribbling in white, yellow, orange, and even green pen. If you cannot see what I'm writing during the lesson, guys, for whatever reason, if the screen decides to just disappear or anything like that, please let me know, all right, so that I've got an opportunity to fix it. Okay. Right. So you should be able to see everything on your screen now, grade 9s. So let's get going. You guys can write down today's heading and today's date. Today's date is the 22nd of April, and our heading is going to be surface area and volume. So when we talk about surface area and volume, grade 9s, It's actually really important. And even though it doesn't seem like it's too major of a topic for right now, you guys will learn that as we head into the higher grades, especially 11 and 12, your understanding of surface area and volume becomes very important. Okay? There is a topic that you guys will eventually cover called optimization, which is a grade 12 topic, right? And that deals with us spending time trying to literally maximize or minimize the amount of surface area or volume taken up by a certain shape, for example, or something along those lines, right? There are a lot of different examples that we could go through, but let's quickly start by reminding ourselves of some of the basics. You guys should know that surface area is the total area of all the faces of a 3D shape. Okay, please keep in mind that when we speak about surface area and volume, we can only be discussing 3D shapes. Okay, that's really important, guys. So, surface area is the total area of all the faces of a 3D shape. Surface area has a symbol of SA, so you are allowed to use SA as an abbreviation or literally as a symbol when it comes to your solutions that you're writing down. And finally, surface area is measured in square units. Okay. Is measured in square units. What does that mean? We're talking about millimeters squared, centimeters squared, meters squared, or kilometers squared, kilometers squared, right? They are all our squared units of distance. So make sure that you are familiar with all of that information. Next, we need to just quickly revise the concept of volume, and then we'll take a look at some examples. If you guys have any questions, please make sure that you ask me. Right, volume. Right, volume is the total amount of space taken up by a 3D object. So, for example, when I look at something like a cereal box, right, grade 9s, um, we're discussing what we call a rectangular prism. If I'm looking at a rectangular prism and I want to know, okay, what is the volume of this rectangular prism? I'm trying to ask myself, how much space does this shape take up in my 3 dimensions, right? That's why we are working with 3D objects. Now, the other way that you can choose to think of this is how much fluid can I fit inside of this kind of an object? So if I had a jar of water, or a jug, sorry, of water, and I was talking about the volume of this rectangular prism, just as an example, guys, I know this isn't perfect. I would be asking myself how much fluid can fit into this jar, into the rectangular prism, right? It's important for some of you that don't do science. A cubic centimeter, which is quite obviously a unit of measurement for volume, is equal to a milliliter, right? So when I say that something has a total of 90 cubic centimeters, the reason why I brought up fluid or filling something with water is because some people prefer to think of this as filling an object with 90 mils of water. These are not exactly the same thing, right? We can convert between these. I'm just explaining to you guys that if it doesn't make sense for me to say we are looking for the total amount of space taken up by a 3D object in our 3D in our three-dimensional plane, you can also think of it as how much fluid can I fill into a specific object. Okay, only because of this fact over here. That's just something on the side that might be interesting to some of you. Okay, so second, volume has a symbol of capital V. That's no surprise. You are allowed to do this, but you must start the question by stating that volume is equal to V. And finally, volume is measured in cubic distance units. Right. What are cubic units? Millimeters to the power of 3 or cubed. Centimeters cubed. Meters cubed and kilometers cubed. Okay. I hope everything is making sense so far, guys. So what we're going to do is actually dive straight into some examples. I'm not going to sit here and lecture you guys on too much information. That's not necessarily practical. But just actually, one last point I want to write down before we look at examples is the world of formulae. We know, guys, that, for example, when we've discussed the area of a triangle, we know that its area formula is a half times base times perpendicular height. We know the area of a square. We also know the area of a rectangle, right? We have unique formulae for all of these. Please keep in mind that there are also quite a few different 3D shapes that we can work with. So we do, for example, have the area formula, or sorry, the volume formula for things like a rectangular prism. Okay? And just to point this out, guys, you're going to have to sit and figure out on your own which of the formulae makes sense to you, right? If I'm looking at the volume of a rectangular prism, for example, I would be looking at the following. I would say that the volume of a rectangular prism is equal to the length times the width times the height of that prism. Now that's pretty straightforward, and I could figure this out on my own without needing to have a formula sheet. But if I think about a sphere, guys, our 3D circle, the volume of a sphere is 4 over 3 pi r cubed. Now you can try and figure out this formula on your own if you want in a test, but that is going to be really tricky, right? So I just want to point out to you now in the beginning, before we dive into these different examples, that there are going to be some formulae that you are going to be able to find on your own, right? And others, it's just going to be easier for us to learn the formula. Okay. So, guys, with that being said, um, you must also make sure that you are relatively well versed in your area of circles. Okay. So, this is just a note over here. Some formulae are easier to learn. But with that being said, we don't have to memorize every single formula that we find for volume. Okay, I'm going to go ahead and write down a little subheading for examples, guys. You can copy this down as well. If you have any questions, now would be a good time to ask. I'm going to draw our first shape, and the question for our examples is going to be to calculate the surface area and volume of the shapes below. Now, for those of you that are curious, yes, we do run into questions where we work with algebra in measurement grade 9s. So it's very possible, just on a side note, that we are given something like this over here once again. This is a very rough drawing, but let's just say we're given another rectangular prism, right? Something like this over here. And the length of something could be, for example, 20 minus x, while this is x over here, right? Just as an example, and maybe this is x plus 5 for the height of the prism. It is very possible and very likely that at some point we will also tackle examples where we have to discuss how we approach finding the surface area and volume of shapes that contain variables in their dimensions. Okay, we're not going to focus on this too much for now, but I know that a few people are normally pretty curious about that. Nonetheless, let's dive into the very first example. Let's draw ourselves a proper rectangular prism. Right, if you guys can copy these shapes down, I would strongly suggest that you do so, but it's completely up to you guys. Right. Let's start with a simple rectangular prism, guys. I will write down the names in case you guys want to have them, but please make sure that you go and study the names of the different shapes, because your teacher can say to you in a question that we are setting up a science project in the shape of a triangular prism with the following dimensions. And if you don't know how to draw those shapes, you're going to have a little bit of a tough time understanding the question. Okay, so we've got a rectangular prism over here. I'll rewrite the name in a second. Let's do the following. We have 40 millimeters over here. This is going to be 120 millimeters, and the width is also going to be 40 millimeters. Okay, these are the three independent dimensions that you've been given for this shape. Now, when it comes to working on a rectangular prism, remember I said to you that there are going to be some formulae that you can learn off by heart, while others you can try and figure out as you make your way through an example. This is one of those examples. So it's a pretty simple shape over here. I'll give you guys a second to copy once I have finished the question. Okay, so we have a rectangular prism over here. Let's say we started by calculating the surface area of this shape, guys. We can always begin by saying the surface area is equal to SA. Now, remember, surface area means that we're trying to find the area total for the shape, based on all of its individual faces. What that means is, if I look at this shape, which is very similar to a cereal box, I have 6 different sides of the cereal box that I can touch. The left side, the right side, the top, the bottom, the front, and the back. Okay? So maybe for your guys' sake, you don't have to do this in a test or an exam, guys. This will not get you extra marks. But you could say, for example, you want the front plus the back plus the left plus the right plus the top plus the bottom, right? It's not always going to be so easy to label the different sides, but you've got to find a way to keep track of which sides you have already accounted for and those that you haven't. In this case, if we're working on this front plate over here of this shape, we see that it's 120 millimeters long and 40 millimeters tall, right? But we're only working with flat 2D shapes individually on their own before we add everything together. So here we're going to have 120 times 40. The back plate is going to be the same in dimensions, right? So we could even say 2 times this 120 millimeters times 40 millimeters. Please keep in mind that opposite faces of a rectangular prism are going to be equal in size. 2 times the 120 times 40. This can be the front and the back of our shape that we are looking at right now. Next, maybe we want to discuss the left and the right-hand side. The left-hand square over here is 40 millimeters wide and 40 millimeters tall. But I have the same identical plate on the right-hand side of the rectangular prism. So in this case, I would have 2 of the following. A 40 millimeter by 40 millimeter rectangle. It's actually a square though in this case, right? This would represent my left and right sides. And finally, I can do the top and the bottom. Remember, this top piece over here and the bottom are going to be equal in size. Okay? If you guys feel the need to go and write all of the dimensions on every single side of the shape like so, guys, there is nothing stopping you from doing this. It's just that things can tend to get a little bit messy should you choose to do that. If that works for you, go for it. Okay. The bottom plate is 40 millimeters by 120 millimeters. Okay, that's actually similar to the front and back plates. Nonetheless, 2 times 120 millimeters times 40 millimeters. Okay, then you can go ahead and start simplifying everything. Now, again, I want to point out your layout does not have to look like mine. If you wanted to start with the top and bottom, you can do that, right? If you prefer to write everything out as individual values instead of using brackets like this, that is your choice, all right? But 120 mils times 40 mils is going to give us 4,800 times 2. So here we have 9,600 plus 3,200. And again, you can put this all into one long sum, but sometimes it makes sense to break things up into pieces just so that as you go through your work, it's easier to catch where your mistakes were. So when I add everything together, guys, we are going to get a total of 22,400 square millimeters. Please remember, this is a form of area, so you must be careful with your units. So we're talking in millimeters squared. Now, it is okay to expect that your answers are going to be quite big values, right? You need to keep in mind this is the area for every single piece of the shape that you can touch on the outside. The top, the bottom, the left, the right, the front, the back. Okay. Certain shapes are going to have more elements, certain shapes are going to have less. But it is usually going to be a relatively big number. So there we go. That's the first step. We've gone and calculated the surface area for shape number one. Next, we would need to go and take a look at the volume. Now, again, there are many different ways that you can choose to view the concept of volume, right? Especially for the volume of a prism in this case. The way I prefer to see it, and it might be helpful for you to see it, grade nines, is to do the following. If I have a shape like this rectangular prism over here, one of the easiest ways to try and visualize the world of volume is by doing the following. I'm going to ask myself, how much plain old area does the base of my shape take up? Right? What area does this base plate of my rectangular prism cover? Once I've found the area of the base of my shape, if it doesn't apply to every shape, but in this case, we can then multiply by the height of our shape. And you can imagine stacking pieces of paper, right? If I can create a piece of paper that's 40 millimeters by 120 millimeters, like this base over here, and then I stack 40 of those sheets of paper on top of one another, I would be able to figure out what the volume of the shape is, right? So in this case, when we're looking for the volume of a rectangular prism, we need the length times the width, right? Because that's going to give us the area of this base plate. And once we've got that, we can multiply by the height of the shape, right? So the length of my shape is 120 millimeters and the width is 40 millimeters. So I know that the base of my shape here is going to give me 4,800 millimeters squared. But if we multiply by the height, look at what happens with all of the millimeters, all of the units. There's a total of 3 of them that are being multiplied together, right? Again, you can go and put this into your calculator if you wanted to, guys. 120 times 40 times 40 gives me 192,000 millimeters cubed. Remember that volume is measured in cubic units, so you can multiply the values together first, then you can multiply the units together. So in this case, the volume calculation is actually quite simple. We've got a volume of 192,000 cubic millimeters. Again, some of you might be shocked because of the fact that this is quite a large number and you might think that you've done something wrong. That is not the case, guys. Remember, we use volume for all kinds of things. If I was some kind of a civil engineer and maybe I was building a new dam for a specific area, if I wanted to calculate the amount of volume, right, the volume of water that this dam holds, I'm talking about kilometers long, by meters deep, by many, many meters wide, right, meters across. So it's not uncommon for us, especially in realistic examples, to get very big values for our answer, guys. Okay, I'm going to give you guys a second to quickly copy. You've got 2 minutes, and then I'm going to move on to another example, this time looking at circles, because this is something that catches everybody off. Do we have any questions, grade nines? Is there anything you guys would like to ask? If you have a question, type it into the comment box now, please, so that I can answer it for you. Okay. I haven't seen any other questions just yet. So I'm going to move down ever so slightly. You guys can finish copying the information regarding the volume of this shape over here, while I write down number 2. Right, let's talk about a cylinder, grade 9s. One of the more irritating shapes to come across, no doubt, in a test or an exam. Please, guys, just take note that these drawings are not going to be absolutely perfect. I'm just drawing them for reference for you guys, so there might be 1 or 2 small errors, but we're going to work with the shape as is, because all we need is the basic idea. Remember, we're going to calculate both the surface area and the volume of this shape. We are given the following information. Right, I have a cylinder, guys, that is 15 centimeters long, and the circles have a radius of 6 centimeters. That is all the information that I am given. Is that enough information? Well, we're going to find out. Let's begin with the surface area. Remember, surface area refers to the collection of areas of every external touchable surface of a shape. So when I look at this cylinder, right, I know that I can touch the outside, the curved edge that goes all the way around my cylinder, but I can also touch the top and the bottom, right? We can even label our diagrams if we wanted to. We can call this the front, the circle at the back over here, the back, and we can call this the side of the shape, right? Just as an example, you guys can choose to do this however you please. But if I want the total surface area of this shape, I know that I'm going to need the area of 2 circles plus this rounded edge, right? That is everything I have to account for. So if I think about a surface, the surface area of something like a cylinder, guys, we've been through a few different grades now where we have to discuss this idea of the net of a specific shape. right? Now, in this case over here, we would be looking at something like this, guys. If we had to take this cylinder and break it down into its pieces, right, into its net, we would have a rectangle for this curved edge over here, the rounded edge. If you think about it, if I take a simple piece of paper like this one in front of me, you guys should be able to see my little camera at the bottom right of the screen. If I take this piece of paper and I decide to roll it up, you can see that we get our cylinder, right? So for this example, we would also have a top cap and a bottom cap on our cylinder, but a rounded edge like this for a cylinder in reality is just one long rectangle. So we would have a rectangle, but then we would also have two circles that would serve to be the top and bottom of our cylinder, right? So this is what our net for the shape would look like very roughly, guys, just as an example. So this proves what we've just mentioned now. We're going to need to calculate the full area of two circles. Now keep in mind this is not a cone, this is a cylinder, which means that our two circles are going to be equal in size. But beyond that, we also just need the area of this rectangle that we see in between the two circles. So how would we find the area of the circles, guys? Well, we need two circles. So 2 times pi r squared, right? This is how we find the area of a full circle, pi r squared. We'll substitute now. But then if I wanted the rounded edge, or this long rectangle that connects my two circles together, I'm going to need a height, right, or a length. In this case, it's 15 centimeters, right? This is not the most accurate drawing, guys, but let's say that this is the 15 centimeters over here. If I know that this long edge on the side of my rectangle needs to be able to wrap around this circle once, right? It means that the length of this side has got to be the perimeter of a circle. So sometimes it might be helpful for you guys to draw out the shape of the net. The net of the shape, okay? When we talk about the perimeter of a circle, we talk about 2 pi r. So we already have the two circles. Plus, we need this rectangle, which is 2 pi r long and 15 centimeters wide. 2 pi r times the width, or we can call this the length of our cylinder. Right, I hope that that makes sense, guys. So what we've done is broken it down into two pieces, and if you'd like to use some color coding, the pi r squared that we see over here is the area of our circles, while the 2 pi r times the length of the cylinder is the size of the rectangle. So with that being said, we need to substitute pi r squared. What is the radius of my circle? We can see that it is 6 in this case. So we're going to go ahead and substitute 6 into r's place. And in L's place, the length of my cylinder is 15 centimeters. All right. If I were you guys, I would recommend simplifying so that you have an answer finalized in pi and then write it in its decimal form. So in other words, 2 pi times 6 squared. 6 squared is 36. 36 times 2 is 72 pi. Plus, over here, 2 pi times 6 times 15. 2 times 6 is 12. And 12 times 15 gives us 180 pi. So, when we finalize everything, we have a total of 252 pi, which is approximately equal to, and you can then use your calculator, right, which is approximately equal to 791.68. Remember, we are working with surface area and we're specifically working in centimeters, so centimeters squared. Okay, there is a great example of how you guys need to be able to actively solve a problem while you are sitting in a test or an exam scenario. Guys, somebody's asked a fair question. They've asked, is there no faster way to calculate the surface area of a cylinder? It really depends, guys. If you are happy to, save yourself the effort of having to memorize all of the formulae, right? You can then just sit in your test and sort of think about this diagram over here and then calculate it in one straight go like this. That works. If you don't, guys, you then need to know that the surface area of a cylinder has a formula, and this formula is 2 pi r times h plus 2 pi r squared, which is effectively what we had, right? This is the same thing as our second step over here. We've just reordered it, right? It's sort of written the other way around, and instead of using length, they use height. So the only faster way to calculate the surface area of a cylinder would be to perfectly memorize its formula and then go and substitute. Okay, I hope that answers your question. Otherwise, no, there is no faster way. And remember, we need to be able to rationalize like this and split shapes up, because there are instances in which teachers don't have to give you perfectly recognizable shapes, and you have to be able to work with individual components rather than an overall formula. Okay. Nonetheless, guys, you can quickly copy if you would like to. This is how we would find the surface area of a cylinder. I'll leave this little diagram over here on the side for you guys. And this is the formula if you want to write it down. That is the official formula for the surface area of a cylinder. Okay. That does mean that we still have to finish off by speaking about the volume of the shape. We can say that volume is equal to V. Now, I'm going to give you guys 1 second to quickly copy. Somebody then has also asked if I could please do another example of circles. They're a little bit lost. What I will quickly do is finish this example, guys, because we've only got about 15 minutes left. What I will do is I'm going to write some notes down that will help you with the circles, okay? I know that a cylinder can be a little bit of a confusing example, so I'll write some notes with you guys now at the end about the area of circles, and then we can take it from there, okay? Let's wrap up by talking about the volume of this cylinder. Remember, guys, when it comes to working with any shape, when we're talking about volume, surface area, or any of those sorts of measurements, you always need to understand how to measure the perimeter and area of a square, a rectangle, a triangle, and a circle. Okay, these are the four shapes that are really going to impact your understanding of these sections of work. So you need to know how to calculate the perimeter and the area of all of these shapes. Circles in particular are very important, and you must be able to calculate the area and perimeter for a full circle, a half circle or a semicircle, and a quarter of a circle. Okay, so I'll chat about that now at the end of the lesson. Guys, when we talk about volume, remember that volume is a measurement or a measure, sorry, of the amounts of space that a shape is taking up in the 3D plane. We're trying to ask ourselves, if I had to fill this with a liquid, or if I had to stack piles of paper on top of one another to make the shape, how would I do that? Let's think about the volume very quickly in terms that we already discussed the previous example. If I have this cylinder, grade 9s, let's make it bigger. If I'm looking for its volume, it means that I'm trying to figure out how much space this shape is taking up. So how could I do that? Well, just like I said in the previous example, the easiest way to do this is usually going to be to find a base for your shape. In this case, we'll pick the circle. If we can calculate the area of this circle, you can imagine taking multiple discs and stacking them on top of one another, right? Until we have compact enough pieces of paper together to get a full cylinder. So in other words, if we can find the area of the circle, we know that its area is pi r squared. If I take this area and I multiply it by the height of the shape, it is going to give me the total volume. Right? Think about a can of Pringles, for example, right? Those chips. If I find the size or the area of the bottom of that container, and then I pack circles and circles and circles on top of one another, eventually I'm going to fill it up with circles, right? And that's going to tell me how much how much volume that shape holds. So, again, you can choose to think about this logically or practice with the formulae for now, but the volume of a cylinder is going to be equal to pi r squared, the area of the circle, times the height of the cylinder. Okay, that is the official formula for calculating the volume of a cylinder. Okay, so we've got pi r squared times h. We can then substitute. Pi stays as is. R is 6, which needs to be squared, and then multiplied by this height of 15 centimeters. Okay, 6 squared is 36 times 15 is going to give us 540 pi. So we can say that the volume of the shape is approximately equal to, and you always round to 2 decimal places unless otherwise stated, 1696.4 or 6. What are we measuring in? Well, centimeters, but because we're working with volume, it must be cubic centimeters. So in this case, guys, you can see how much more complex the surface area is for this shape, while the volume is actually relatively simple. Again, grade 9s, it's important for me to point out to you guys that you need to decide whether you would prefer to memorize the formulae for these shapes or practice it until you are so happy that you're able to derive the formulas on your own, right? So for example, we said here with the cylinder, if I have pi r squared as the base of my cylinder, the area of the base of my cylinder, if I multiply that by the height, it's going to stack that many areas, that many circles on top of one another to give me the volume. So to me, that feels very intuitive, but to some of you guys, you might still want to practice this or get familiar with it, right? And that's completely fine. What I would recommend you guys do is take a look at the formulas. You do get some of them on your formula list, your formula sheet if your teachers are feeling kind, okay? But I would recommend that as you guys practice, you work towards being able to derive the formula on your own, okay? For the more basic shapes, not for all of them. There are some shapes that are a little bit more tricky, okay? I hope that this makes some sense, grade 9s, and that you guys aren't too lost. All right. So guys, I just want to quickly touch on some of your circle theory because it's really important that you guys are up to date with all of that. Then we will be done for today. Okay, we've only got 7 minutes left. I do want to still quickly show you iRainbow to give you an idea of where you can find a quiz. So you have got 1 more minute to quickly copy, guys. And then I'm just going to move on to wrap up with today's lesson. Remember, the point of today's class is not to teach you about the formulas, right? You can Google the formulas. They're probably even in your textbook. What I'm trying to do, guys, is show you some different approaches or styles of thinking that you can use to approach these questions, right? Obviously, we need to know the basics. We need to know what volume is, how we measure it, and so on and so forth. But beyond that, we need to make ourselves more comfortable with a specific style of thinking that works for us. Somebody asked how I got to this answer over here in the end. Remember, we have pi r squared times h. I substituted r, which is over here, 6 centimeters into r's place. I then took the height, which is this 15 centimeters, and put it into h's place. 6 squared is 36 pi, and if I multiply 36 by 15, I get 540 pi. Now, guys, you should be looking at getting some kind of a scientific calculator. Again, if you look at my camera that's at the bottom right of the screen, this is an example of the silver calculator that I use, but this is the scientific calculator from Casio. You should be aiming to get one of these because you're going to use it until the end of high school, especially if you stick with maths core. But on here, if you type in 540 pi and you use the S to D button, the surd to decimal, you will see that it comes out as 1696.46, which is the answer that I've written down. Okay, so that answer comes straight from my calculator. As far as the units are concerned, we always measure volume in cubic units. And because this example gives us information containing centimeters, our answer must be written in terms of centimeters, even if we are talking in squared or cubic values. Okay. I hope that that answers your question. Okay, guys, I'm going to come back and quickly show you one or two more things about circles. But for those of you that are relatively comfortable with your circles, I want to quickly show you iRainbow. So just give me a second. I'm going to change my screen. You're going to see that I will pop up on your screen all of a sudden. Don't worry, that is me. So you guys should have access to iRainbow, and yours isn't going to look all that different from mine. Okay? Um, when you open your iRainbow, you should be greeted with the following screen. And for the sake of today's discussion, we are in the topic of measurement, which is here in the right-hand column. So you can click on that. And then we are talking specifically about surface area and volume of 3D shapes. Now, guys, it really is important that you please understand that surface area and volume is not just 1 hour worth of work to cover, right? You should be going through a lot of this on your own. And like I said, I'm mostly focused on trying to show you a style of thinking. So we can click on surface area and volume over here, and you can see that there are a whole variety of different quizzes. We talk about the surface area of prisms and cylinders separately. We then discuss volume for prisms and cylinders separately because those are very common shapes, right? We then also talk about doubling dimensions and capacity as well, which I'm not going to talk about now, but you can go and look at. If I press back, guys, and we go into area and perimeter of 2D shapes, you will see that there are formulas. There's revision on circles, guys, which I think is a great thing for you to go through if you want to brush up on your understanding of circles, right? And this is a relatively convenient way to do it because it's accessible and it doesn't take too much time. You can go and look at triangles, parallelograms, rhombi, trapeziums, composite shapes, and so on and so forth. Now, I did talk about some of this last week, and if you do want to watch the recording of last week's lesson, you're more than welcome to find the recording either on YouTube or on Facebook. It will have been on the 15th of April. But guys, go and look through all of this information. If we go back to surface area and volume quickly, and just as an example, I click on the volume of cylinders, right? You're initially going to be greeted with an entire document explaining what we're really trying to find when we're looking at the volume of a cylinder, right? It mentions very briefly how the formula is derived, but it also goes through a few examples that might help you to make a little bit more sense of the topic. When you are done with that and you press go to the questions, there is a 25-minute video over here that I have created for you guys that explains how we calculate the volume of prisms and cylinders, right? I am not going to go through all of it now, but I chat about a lot of the really important information that we need to know when it comes to these shapes, and I go through some very simple examples before progressing to the more complicated examples. So not only do you have a PDF, you also have a video, for example, here explaining the volume of triangular prisms, right? This is another example you can go through. Here's cylinders as well, and it's even got examples of compound shapes for volume. So we discuss here how we have a triangular prism and a rectangular prism, and we need to calculate its combined volume. Okay, so guys, I would strongly recommend you go and read the PDF and then even go and watch this video and then try the quiz itself. Okay. Please take note of the fact that when you do try the quiz, information will be given to you, but you need to sit and solve your questions on a piece of paper in front of you. You can see that it takes quite a lot of writing, right? A lot of working out. So please do not just try and guess the answer. And guys, when you do submit your full quiz, it'll give you an idea of how you did right here under your reports. Okay, I don't have a report for that topic, but you can use this to assess your understanding and figure out whether or not you need to spend more time understanding circles, for example. All right. So, guys, to those of you that are already happy with everything we've discussed in today's lesson, please keep in mind that you have this resource available to you. You can go back and watch the video, not only the recording of today's session, but the video uploaded onto the iRainbow software, and then also use the quizzes to help you. All right, I think it's a really valuable tool, so I would strongly recommend you guys use it. But just very quickly, guys, to those of you that are happy, you are more than welcome to leave. But I then just quickly want to answer somebody's question about circles and volume. So I'm going to start by sharing my screen again. For those of you, like I said, that are happy, you are more than welcome to leave, guys. But just very quickly, for those of you that are interested, yes, we are already over time, but I want to give you guys just one or two more tips or pieces of information. Okay. If I have three circles, guys, there's some important information we need to understand. We have most commonly full circles, semicircles, and quarters of a circle. All right? So, very quickly, let's say I'm focused on this half and focused on this quarter over here. We have a full, half, and a quarter circle. The perimeter, let me do it like this instead, guys. The perimeter of a full circle is always going to be 2 pi r, and the area of a full circle is always going to be pi r squared. The perimeter of a semicircle The perimeter of a semicircle is slightly more unique because we have to consider we need half of the perimeter of a full circle, right? So as opposed to having 2 pi r, we just have pi r plus the diameter for the perimeter of a semicircle. The area of a semicircle is going to be half pi r squared, right? Because it's half a circle. And when we look at a quarter of a circle, guys, again, you can choose to view this in two ways. We need a half pi r plus, you can either see this as a radius or two radii or a diameter. And finally, the area is going to be a quarter times pi r squared. Okay, so for a full circle, the area is pi r squared. For half, it's half pi r squared. And quarter of a circle, it's a quarter pi r squared. As for the perimeter, guys, those are things that you'll just have to remember to learn. Right, this is a half pi r plus my 2 radii. In this semicircle, we have pi r for the arc, and we have diameter, the length of the diameter as well. While the perimeter of a full circle is quite literally the full circumference of the circle. Okay, so if you guys are a little uncomfortable with the idea of dealing with circles in a measurement context, make sure that you know all of this information first. All right. I'll give you guys a second to copy, guys, but we are already out of time for today. Please make sure that you make note of this. You do need to understand it. If you have any questions, guys, now would be the time to ask, but please keep in mind, as much as I wish I could answer all of your questions about this entire topic now, I will not be able to in just one session. Okay. But if there's anything you're really, really curious about, you're more than welcome to ask and I'll try and answer it quickly. Okay. Well, grade nines, that's going to be it for today, guys. I really hope that you got some value from today's lesson, that you understand something a little bit better after today's hour that we've spent together. Guys, please remember that you can access the recording of today's lesson for free on this YouTube, on the iRainbow Education YouTube channel, or on the iRainbow exclusive community Facebook page. Okay, whichever you have access to. But guys, that's going to be it for today. I wish you the best for the week ahead and any tests or exams you might have. But guys, remember our next lesson is going to be next week, Tuesday, from 5:30 to 6:30 in the evening. All right. Thank you so much, guys. Have a fantastic evening further. I'll speak to you all then.